In the last video we talked about concentration. And we said that concentration was an amount of solute. For example, it could be moles of solute. That's an amount of solute per an amount of solution. It could be moles of solution, it could be grams of solution, it could be liters of solution. That's the one we'll pick. And we're going to define that concentration unit, moles of solute per liters of solution, as molarity. We're going to give it a symbol, capital M. Whenever I write a capital M from now on, it's an abbreviation for this. It's an abbreviation for moles of solute per liters of solution. So if you see on a bottle in the lab 6 molar NaCl, you'd say that M as molar. Six molar NaCl. That means that you have 6 moles of NaCl per liter of solution in that jar. Different solutions can have different concentrations, of course. Depends on how much salt you put in there. Let's see how chemists use this concentration definition to make solutions. Suppose I wanted 6 molar NaCl solution. Suppose I wanted a liter of it. Well, from the definition here, I can see that if I get a flask that looks like this, often it has a little bubble there, but not always. It's got a funny kind of a bottom that's shaped like this. This is called a volumetric flask. And this neck up here is kind of a ground glass neck, and it's designed so that it has a stopper, usually a glass stopper, but sometimes plastic, that fits exactly into that ground glass joint there. So what you get is a watertight seal. And there's a little mark here, a fiducial mark, that the manufacturer etches on the side. If this is a 1 liter flask, it means that you have 3 or 4 significant digits when you fill the flask up to that mark. Now, just like the other glassware that we've dealt with in the course, here's the fiducial mark. The mark is placed so that you have to read across the bottom of the meniscus. And if you fill this thing up so that the bottom of the meniscus is grazing that mark, and it's a 1 liter flask, then you know the volume to 3 or 4 significant figures depending on how good your flask is, whether it's grade A, class A, or other classes. Alright, so if we wanted to make 6 molar NaCl solution, we could put 6 moles of NaCl down here. So my recipe is add 6 moles of NaCl to 1 liter flask. Then what I'm going to do is I'm going to add water to this. I'm going to add some water and mix, some more water and mix, so that I keep mixing it as I'm adding the water until the bottom of the meniscus touches the fiducial mark there's my recipe for making that solution, and I can work out the recipe if I know what concentration I want. Now, a lot of times in real life, you're going to be faced with recipes that will ask you to supply some 6 molar NaCl or some particular concentration of some other chemical. And it will be your job as a lab worker to know how to make it, to know this recipe. Now, the trouble with the recipe is that I don't have a molometer. I can't go and measure out 6 moles of NaCl directly. But we already know what to do with this from a previous chapter. I can weigh grams of NaCl. So what I need to do before I execute my recipe here is figure out how many grams of NaCl that is. If I do that, then I can go weigh out that many grams of NaCl on a balance. So let's remember how to do that. So if I want 6 moles of NaCl, and I want to turn that into grams of NaCl, what do I need? Well, whenever you are trying to relate moles to mass, you need a molar mass. So I need the molar mass of this. And very roughly, this is like, I don't know, 23.0 U on the periodic table. And this is very roughly on the periodic table 35.45 U. So if I add those together, I get something like 58.5, let's say, very roughly. So 58.5 is the molar mass of NaCl. That's how many grams of NaCl is in 1 mole of NaCl. And remember, we spend quite a lot of time doing gram to mole conversions for compounds before. I'll take the red map here. I know moles of NaCl has to go on the bottom here. So we're back to this again. And I know I'm trying to get into grams of NaCl and put that on top. So that'd be like 58.5 is in every 1 mole. And I could figure out, what the mass of NaCl I needed to weigh out is. If this is about 60, and I have 6 times 60, what is that, 360 grams roughly? Work it out yourself and see how many grams of NaCl you need. Then what I would do is I would go back and I would place that many grams of NaCl, about 360 grams of NaCl, into the bottom of this flask, and then add water and mix it. Add water and mix it. Add water and mix it until I come up to the meniscus. Now, why don't I just dump it all in the bottom and then add water up to the top? Well, what I'm going to see is that when you add water to something, the volumes don't always add up. So if I add like a liter of water to a liter of salt, the total volume of that after they're mixed is not going to be 2 liters. It's going to be less than 2 liters, in fact. So the volumes don't add up. And if you go and you dump your 360 grams of NaCl into the bottom here and just dump the water in until you come up here and then mix, you'll see that the liquid level will drop back down to about there. And then you can fix it by adding more water until you come up to the mark and mixing it again. But you have to keep on doing that until you come up to the mark here, because the volume of water and the volume of salt are not additive. So that's how you actually make a solution. Let's look at a slightly more complicated example. Suppose I want, 250 milliliters of 0.100 molar NaCl. How do I make it? All right. What I'm going to do is go and grab off the shelf a 250 milliliter flask. Volumetric flask is the right tool for this job. Then I am going to figure out how many grams of NaCl I need to dump in there to make up a solution with this concentration. Now, how do I do it? Okay, well, in this case, I don't have 1 liter. But what I can do is take my 250 milliliters of solution and I can turn it into grams of NaCl that I need. It's a unit conversion, really. And this molarity gives me a link. It gives me a link between a volume of solution and an amount of solute. So anytime you need to link volume of solution with amount of solute, you need a molarity. You need a molarity. Let's put a box around this. This is a particularly important concept here, that when you're making a roadmap to convert a volume of solution into an amount of solute, you're going to need this as your critical link in the conversion. Now that's a critical link, so I can drop it in the middle. If I look at this, remember I said the capital M you can cross out, and you can put, instead of writing it like this, write it like this. That's how many moles of NaCl are in a liter of solution. So this is a link between moles and liters. If I drop moles of NaCl into my roadmap close to grams, and I drop liters of solution into my roadmap close to milliliters, this gives me the link 0.100 moles of NaCl is 1 liter of NaCl. So my strategy is go from here to here, here to here, and here to here. There's the link you need. So this is just a unit conversion. It's not anything new. The only new thing is that we have a new way to link things. We know how to link now a solution volume with an amount of solute. Moles if you're using molarity. And then I need a gram to mole link, and so I need a molar mass with that. And that's our 58.5 grams of NaCl in 1 mole of NaCl. Okay, and now I need a link between milliliters and liters. And we know how to do that. 1 milliliter is 10 to the, okay, milli is minus 3. So there's my link there. And I have a continuous set of stepping stones from the amount of solution that I want to make to the amount of NaCl that I need to weigh out. So let's put that together. You might be a little rusty on your unit conversions, but the reason we did all that stuff in the beginning is so that we could use it later, and you will use it throughout the rest of the course and through 202. I know milliliters has to go on the bottom of this first conversion factor to cancel the units out. Here's my first conversion. So that and that cancel. Okay, now in my second conversion factor, what has to go on the bottom? Has to be liters, because that's what has to cancel out. So this goes from liters to moles of NaCl. And it's 0.100 moles of NaCl in 1 liter. losing my marker here. Okay, what about our final conversion factor? Okay, well, I crossed out liters. Now I have moles of NaCl. I want to cross that out. So that has to go on the bottom. And here's my last conversion factor. 1 mole of NaCl is 58.5 grams of NaCl. And that'll do it for me. I can just go ahead and do the math here. So this is going to be 0.25 times 0.1 is 0.025 times 60, whatever that is. That's going to give me my answer in grams NaCl. And then my recipe here is take this many, whatever I get here, this many grams of NaCl, plug it up into this, plug it up here and tell my, whoever's looking at this problem, this is how you make it. You weigh out this many grams of NaCl, put it into the bottom of a 250 milliliter volumetric flask, add water, mix, keep on going like that until you get the bottom of the meniscus to come up to the fiducial mark. So that's how you use molarity to figure out how to make a solution.